In 2020, GPT-3 shipped. Raw. If you asked it, how do I bake a cake? It might answer with recipe, or it might answer with 3 more questions about baking, or it might drift into a chapter of a novel. GPT-3 was a magnificent completion engine and a hopeless assistant. Then, in 2022, InstructGPT shipped. Same model, roughly the same size. Suddenly it answered your question, cleanly, politely. What happened between them is called RLHF, and it is one of the most consequential technical moves of the decade. Welcome back to Lecture 10. Today, how you actually turn a raw language model into a helpful assistant. We are going to cover the 3-stage RLHF recipe from Christiano 2017 and Ouyang 2022, then Constitutional AI from Bai 2022 at Anthropic. Then we will step back and talk honestly about the alignment problem, what these techniques do not solve. V6 was about evaluation, how we measure a model. This video is about how we train a model to do what we want, once we have decided what good means. Because pre-training alone does not give you a helpful assistant. Pre-training gives you a very fluent completion engine. The gap between influent and helpful is what alignment fills. And Ouyang 2022 InstructGPT was the paper that showed the field how to actually do it. Today's puzzle. You can hand-label millions of examples of good answers and fine-tune the model on them. That helps a lot. But you cannot write down in code all the things you want the model not to do. Do not be racist. Do not help with weapons. Do not sycophantically agree with wrong claims. There is no clean loss function for be a good assistant. So, how do you optimize for something you cannot define? Answer: you let humans compare pairs. Today's 3 beats. First, RLHF, the 3-stage recipe. Christiano 2017 for the algorithm. Ouyang 2022 for the LLM demonstration. Second, Constitutional AI. Bai 2022 at Anthropic. Replace part of the human preference labor with the model critiquing itself against a written set of principles. Third, the alignment problem. What these techniques really do, what they do not do, and why the term keeps expanding. Beat 1. RLHF, Reinforcement Learning from Human Feedback. The core idea comes from Christiano and co-authors at OpenAI, RLAIF 2017. Originally used on Atari games. If you cannot write down what good gameplay looks like, you can still show a human 2 clips and ask which is better. From enough pairwise comparisons, you can fit a reward model that scores individual clips. Then you use that reward model as the training signal for a reinforcement learning agent. Same trick, applied to language, is the modern recipe. Now the language version. Ouyang and co-authors, InstructGPT, NeuraPS 2022, 3 stages. Stage 1, Supervised Fine-Tuning, SFT. Take the pre-trained LLM hire annotators. Have them write high-quality answers to a set of prompts. Fine-tune the model on those demonstrations. This alone dramatically improves helpfulness. But it is not enough. Stage 2, the reward model. Take the SFT model. Sample multiple outputs for the same prompt. Have annotators rank them. Fit a small model, usually a slightly smaller LLM, to predict human rankings. Now you have a differentiable scalar that approximates human preference over answers. Stage 3, reinforcement learning. Use the reward model as the training signal for the SFT model. Usually with proximal policy optimization, PPO, constrain how far the model drifts from SFT with a KL penalty. Every response you generate gets scored, and you update to produce higher scoring responses. Beat 2, Constitutional AI. Bai and co-authors at Anthropic, 2022. RLHF has a scaling problem. Human preference labeling is expensive and slow. Bai and team asked, can we replace some of the humans with the model itself, plus a written set of principles? That written set is the Constitution. It includes principles like do not encourage illegal actions, be honest about uncertainty, do not be dismissive to the user. In practice, tens to hundreds of such principles. The Constitutional AI training loop. Sample a response. Ask the model itself, critique this response against these principles, ask it to revise. Now you have a self-improved response. Do this at scale, and you get a dataset of preference pairs where the winner is the revised version. Fit the reward model on that. Bai's team called this RLAIF, reinforcement learning from AI feedback, where AI takes the role that humans had in RLHF. Humans still write the Constitution. Humans still spot check. Humans no longer label every pair. A quick note on newer variants. Direct preference optimization. Rafailov 2023 at Stanford. Skip the reward model entirely. Derive a loss function that directly moves the LLM toward preferred responses and away from rejected ones. Same input, preference pairs. Simpler, more stable training. DPO has largely taken over as the standard fine-tuning move for smaller labs. RLHF still dominates at the frontier. The label RLHF has become shorthand for the whole family, even when the RL step is not literally PPO. Beat 3. The alignment problem. Big term. Different people mean different things. Narrow alignment. The model behaves as its designers intended for the tasks it is deployed on. That is what RLHF and CAI mostly do. Broad alignment. The model's overall goals and behavior remain aligned with human values as the model becomes more capable, potentially superhuman. That is the topic that keeps AI safety researchers up at night. And nothing about the training recipes we have covered solves the broad case. Even the narrow case has known failures. Sycophancy. The model learns that agreeing with the user is preferred, so it agrees with wrong claims. Reward hacking. The model learns tricks that spike the reward model but produce bad outputs. Mode collapse. The model becomes bland and repetitive because that maximizes preference model score. Overrefusal. The model refuses reasonable requests because the reward signal treated end refusal as safe. Every deployed RLHF system has some of each. Researchers spend serious time hunting them. The honest picture. RLHF and constitutional AI turned raw LLMs into products. That is a massive engineering achievement, and they have moved the field a real measurable distance on helpfulness, harmlessness, and honesty. They have not given us a theory of what a model actually wants, or a proof that scaling them up preserves the alignment. The word alignment spans a spectrum. On the practical end, we are shipping. On the theoretical end, we are still asking basic questions. 3 takeaways before the quiz. 1. RLHF is a 3-stage recipe. SFT on human demonstrations, a reward model fitted to pairwise preferences, and RL, usually PPO. Using that reward model. Christiano 2017 introduced the algorithm. Ouyang 2022. InstructGPT scaled it to LLMs. 2. Constitutional AI, Bai 2022 at Anthropic, replaces most preference labels with the model critiquing itself against a written set of principles. RLAIF scales further. Humans still write the Constitution. 3. Narrow alignment ships. Broad alignment is open. Known failure modes, sycophancy, reward hacking, mode collapse, overrefusal, persist and are the subject of active research. Quiz 1. What are the 3 stages of RLHF as demonstrated by Ouyang 2022 InstructGPT? A tokenize, embed, attend. B. Supervised fine-tuning on human demonstrations. Reward model training on pairwise human preferences. Reinforcement learning, usually PPO, against the reward model. C. Pre-train, prompt, generate. Or D. Encode, decode, sample. B. SFT, RM, RL. That is the recipe that turned GPT-3 into ChatGPT. Same model, radically different manners. And it built on Christiano 2017 Deep RL from human preferences, which had shown the trick on Atari 5 years earlier. Quiz 2. What is the key innovation in constitutional AI? A bigger transformer than GPT-4. B. Replace most human preference labeling with the model critiquing and revising its own outputs against a written set of principles, a constitution, aka RLAIF. C. A new tokenizer. Or D. A rule-based expert system. B. Humans write the rules. The model applies them. RLAIF scales past the throughput ceiling of paying humans to label every pair. Humans still write the Constitution and spot check. The bottleneck shifts from labor volume to principle design. Quiz 3. Which of the following describes the honest state of the alignment problem? RLHF, and constitutional AI have completely solved alignment. B. Narrow alignment helpfulness, harmlessness, honesty is shipped and improving. Broad alignment goal specification, corrigibility, deception risk in more capable models is an open research problem. Even narrow has known failure modes like sycophancy and reward hacking. C. Alignment is impossible. Or D. Only OpenAI has aligned models. B. Massive engineering, unfinished science. RLHF and CAI ship the products, but sycophancy, reward hacking, mode collapse, and overrefusal all persist. And the harder theoretical questions about broader alignment remain open. Back to the puzzle. You cannot write down what a helpful assistant is, but you can show pairs. That trick, comparison over definition, is the whole reason RLHF worked. Constitutional AI extends it by writing principles down, and the alignment problem is what happens when you ask the same question about more capable models. Next video, the 3 biggest open problems in the field today. Next time, the 3 open problems in computational linguistics right now. Long context reasoning, low resource languages, interpretability, where the frontier actually is. Hit subscribe.